good afternoon for everyone. My name is FIRLIANDA Imansyah from 10 November Institute of Technology in Indonesia, and today I will be presentation my research about the environmental impact analysis of natural gas production and distribution process using life cycle assessment. To an introduction, natural gas is often associated with a petroleum in the extraction process from earth which have the same content in the organic decomposition of a sediment in the impermeable layer. Natural gas consists mostly of a methane, ethane, and a small portion consists of a nitrogen, oxygen, carbon dioxide, and hydrogen sulfide. Despite its use as a full natural gas is a source of hydrocarbon from other industrial raw materials such as a petroleum raw material and the main source of elemental sulfur for the chemical industry. Gas production activities are in a series of complex processes involving various gas industry activities starting from upstream, main process to downstream. Upstream activities include exploitation activities through drilling wells containing a mixture of crude oil, natural gas, and water to separate each type of oil and gas in the main process. Downstream activities include a marketing activities to the community and the other company industries. The main process activities include a natural gas processing activities into the derivative of a natural gas will be transmitted but with a downstream activities into LNG, CNG, or LPG. The impact of industrial activities on the production and distribution of natural gas, such as global warming potential, human toxicity, acidification, and eutrophication, is generally the greatest. Seeing the impact resulting from the activity of the natural gas production and distribution sector, it is necessary to analyze the impact assessment using the life cycle assessment method. Life cycle assessment is a technique for assessing the potential environmental impact associated with a product, process, or service over its lifetime. The first is to measure and evaluate the environmental performance of a product or process from raw material to the return to nature to help a decision maker to choose among alternative products and the processes. The use of this analysis used the Cimabro software as a tool for analyzing energy savings and reducing greenhouse gas emission, energy audits, and the global environment. The focus on the product lifecycle as well as the efficient use of a resource in the form of land, water, energy, and a natural resource order. There are four steps in the LCA. The first is a goal and scope. The second is lifecycle inventory. The third is lifecycle impact assessment. And the last step is an interpretation data. It is necessary to carry out the non-uncertainty analysis to support environmental impact studies using the LCA method. Uncertainty analysis is a systematic procedure for measuring the uncertainty that appears in the LCI result. The effect of a model imprecision, input uncertainty, and data variability. Uncertainty analysis provides information about the distribution of the output data due to the spread of the input data and the other source of uncertainty. The probabilistic nature of the uncertainty process can be conceptualized by probability distribution. A significant source of uncertainty is the use of input and output data on the LCI. The quality indicator in the data quality assessment are needed to reveal the representativeness, significance, and harm of the data. Data quality indicators are a reliability, completeness, temporal correlation, geographic correlation, and advanced technology correlation. The result, the first, is the goal and scope. The purpose of this study is to analyze the impact reduction program based on the analysis of the LCA study of natural gas production and distribution processes. The analysis is carried out by looking at the overall input and output of each activity unit, starting from the process of extracting natural gas from the well to becoming a distributed product. The scope of the LCA study carried out is a cradle to gate from a natural gas extraction from wells, gas processing and secondary processing to produce natural gas product until natural gas products are distributed. The functional unit used per 1 ton of natural gas production in 1 year 2020. The data used is a secondary data including materials, product, use of the chemical, energy use, water use, land use, emission generated based on an actually company data that has been published. The second is a life cycle inventory. At this stage, input data such as on the main process and emission from the processing unit during the process. The secondary data used is specially obtained from the production and distribution process of natural gas. The result of this stage will later be described in a flow sheet or a process tree. After data collection and identification process with a purpose and scope is carried out in a calculating LCI. The result of this network processing provided information on the relationship in each process that influence the impact contribution. In the data collection process, it is necessary to carry out data verification, which aims to ensure and document to the data used is appropriate and the data report reflects the actual data. Data verification is the process of evaluating data and the completeness, correctness, and the sustainability of data against applicable methods, procedure, or requirements. Verification can be carried out by personnel involved in the data collection or data analysis makers or external data verifiers. It is necessary to validate the data by involving mass balance and data quality assessment. Data quality is a special characteristic of data expressed through the information about the data, such as information about reliability, completeness, temporal correlation, geographical correlation, and the further technological correlation. Assessment of the data quality can be done using the pedigree matrix with the 5 data quality indicators. The third step is a first sub-step is a characterization. All elementary data flow in the LCI is classified in a certain impact category, which is the multiplied with by a characterization factor and are added up by all relevant intervention to produce our impact score in a certain impact category. Based on the table and diagram, it shows that at the characterization stage, the natural gas production process produces an impact a greater score than the natural gas distribution process in a 6 midpoint impact categories and 3 categories of an endpoint impact. This is because most of a natural gas product are used for fuel gas as an energy source. Only a small portion of the natural gas product are sent to natural gas distribution, so that is affect the normalization of the data inventory value that affect the impact of category score. The second substep of a normalization is done to facilitate the analysis in comparing the magnitude of the impact between categories of effect. Based on the table and diagram, so that the normalization stage of the natural gas production process produce the largest impact on the category of fossil resource scarcity effect derived from a natural gas taken from the nature to be used as a fuel gas and natural gas product. The third substep is a weighting, is the process of converting indicator results from the different impact categories using the weighted factor. The environmental impact category after the weighting will be produced a single score with a point unit based on the table and diagram, so that in a single score the natural gas production process, produce an impact with a greater score than the natural gas distribution process in the 3 endpoint impacts categories and the total impact score. Therefore, the production process of the 1 ton of natural gas produces in an impact score of 5.3164 point, which is greater than the distribution process of a 1 ton of natural gas of 0.1450 point, or the natural gas production process produces an impact of 36.67 times greater than the distribution process natural gas. The fourth step is the interpretation. Hotspot analysis is a scheme based on the value of the largest percentage of the characterization and weighting of the production process and distribution of natural gas. Based on a figure, to simplify the natural gas production process, the single score percentage of the natural gas production process unit is not fully defined and only the process unit will the largest single score percentage. The highest single score, the percentage of the three priority process unit, is found in the compressor C1A process unit at 11.5%, compressor C1B at 11.7%, and the glycol reboiler at 11.3%. The impact category of the glycol reboiler, compressor C1A, and the compressor C1B mostly comes from emission resulting from the use of fuel gas. Based on a figure to simplify the natural gas distribution process, the single score percentage of the natural gas production process unit is not full dipstick. Only the process unit with the largest single score percentage, the largest single score percentage from the priority process unit, is in the flare stack process unit of 95.6%. Uncertainty analysis of the uncertainty of the production process and distribution of natural gas based on the cumulative effect of the data variability based on the data quality assessment. The stage of uncertainty analysis are probability distribution and evaluation of uncertainty analysis results, which are described as follows. The probability distribution of the data is determined based on the data quality assessment score to determine the value of the uncertainty factor to calculate the square of the geometrical interval standard deviation of 95% with a log normal distribution type. The natural gas production by entering the uncertainty factor of emission data to produce 1 ton of natural gas, the total value of the resulting impact is in the range between 4.85 until 5.87 point. And the natural gas distribution by entering the uncertainty factor of emission data from the distribution process of 1 ton of natural gas, the total value of the resulting impact is 0.14496 point. The conclusion from the analysis of the life cycle assessment study on the production and distribution process of natural gas are: the first, the production process of 1 ton of natural gas contribute to a greater impact is 5.3164 point, with the most dominant environmental impact being a fossil resource scarcity, and in the distribution process of 1 ton of natural gas is 0.1450 point, with the most dominant environmental impact being a stratospheric ozone depletion. In the natural gas production process, the largest environmental impact contribution comes from the compressor C1A, compressor C1B, and glycol reboiler process unit. In the natural gas distribution process, the largest environmental impact contribution comes from the flare stack process unit. The second is uncertainty analysis of emission data of 1 ton natural gas production process give an environmental impact being a 4.85 until 5.87 point, and the distribution process of 1 ton natural gas contribute is 0.14496 point to environmental impact. Thank you for the presentation.
Thank you very much for your presentation.